Finding the nth term of a sequence is a really popular and important exam question in GCSE Maths. And you can see here I've got a number sequence that begins 7, 12, 17, 22, 27 and 32. The key aspect here is that we're trying to use a bit of algebra to find the general term of the sequence rather than the next term of the sequence. And this strategy will always work for all kinds of nth term questions in the exam. So what I'm going to do is I'm just going to start off by putting pattern numbers in a small little circle here. So pattern number 1, pattern number 2, pattern number 3, pattern number 4, pattern number 5 and pattern number 6. So I've now got numbers, pattern numbers attached to each of those numbers. I'm now going to construct a series of curvy arrows that just represent the jump in the sequence terms. From 7 to 12 I have plus 5, and from 12 to 17 I have plus 5. I can see that 17 to 22 is plus 5, 22 to 27 is plus 5, and 27 to 32 is plus 5. So an encouraging start which indicates to me that I have a linear sequence. So I know that 5 has got something to do with the rule. Now when I'm finding the nth term of the sequence, what I actually do here is with this jump here, plus 5, plus 5, plus 5, plus 5, I know that the rule has something to do with 5 times n. Now I'm going to write 5n here, because as we know in algebra, 5n means 5 times n. So I know the rule is almost equal to that, but I actually need to compensate to make it work. I go back to the first pattern and I say 5 times 1 is 5, but I want 7. I go to the second term, 5 times 2 is 10, but I want 12. Go to the third term, 5 times 3 is 15, but I want 17. And I can see that to make the rule work, to make it compensate, if I just add 2 here, I've actually successfully obtained the nth term of the sequence. So 5n plus 2 is the correct answer to finding the nth term of that sequence. And the great thing about this solution is that if I wanted to work out, say, the 100th term, where n equals 100, I don't have to write the number sequence all the way to 100. I can just go 5 times 100 add 2, which would be 502. So there's actually a purpose for finding the nth term of a sequence. I can then use the algebraic rule to find future terms in that sequence. For my second example, here I have the numbers 1, 3, 5, 7, 9 and 11. I'm going to deploy the same strategy here, so I'm going to put pattern numbers here, 1, 2, 3, 4, 5 and 6. So once I've created my own pattern number, I do my curvy arrows again to look at the jump, and I can see that there's a consistent 2 involved here. So I put plus 2, plus 2, plus 2, just like that. So I know the rule is something to do with 2n, so I write down 2n. Now for this next example, if I go back to the first pattern number and I write 2 times 1, I get 2, but I only want 1. If I go along here, 2 times 2 is 4, I only want 3. 2 times 3 is 6, I only want 5. So to make this rule complete, the compensation here is just to take away 1. So the nth term of that sequence is 2n, take away 1. And again, if I wanted the 100th term here, 2 times 100, take away 1, 199. So finding the nth term of a sequence, if you work systematically, giving a pattern number and then curvy arrows to look at the jumps, we know that this constant difference always appears here, just before the n, as we know that's a coefficient of n, so that number there secures the number that this sequence is going up in. Now sometimes in the GCSE exam we have a number sequence that actually goes down each time. I've got 22, 18, 14, 10, 6 and 2. Now I'm going to number these patterns 1, 2, 3, 4, 5 and 6. And the significant difference here is that the gap between 22 and 18 is 4, but it's actually going down by 4. So I'm going to write minus 4 there. And likewise between 18 and 14, the difference is again going down by 4, so I'm going to put minus 4 there. Between 14 and 10, I've got minus 4. Between 10 and 6, I've got minus 4. And 6 and 2, I've got minus 4. So in actual fact, this particular sequence has something to do with minus 4 times n. And I look at that and I think to myself, okay, so what's the number I'm going to use to make that number sequence work? And if I go back to my first pattern, n equals 1 here, because these are the values, n equals 1, n equals 2, n equals 3. If I pop n equals 1 into here, I've already got minus 4 times 1, which is minus 4. So what I need to boldly do is to explore what number needs to go on the end to make the rule work. And I can see that because it's already starting at minus 4, I need a number like 26 here to make that rule work. Because if I just put this to the test here and say minus 4 times 1 is minus 4, if I add 26 I get 22. So that one's okay. Go along here, if I put n equals 2 into here, minus 4 times 2 is minus 8, and minus 8 plus 26, great, that's 18. Likewise here, if I put n equals 3 into here, minus 4 times 3, minus 12, plus 26, and I get my 14. So I'm safely secured now that the nth term for this particular sequence is minus 4n plus 26. Some students write 26 minus 4n, they're both equally acceptable results, but for this nth term for sequence, minus 4n plus 26 is the correct answer. And just in summary for nth term for sequences, if we number our sequences along the top here, if we draw these curvy arrows representing the jump from one number to another, the constant difference here just goes before the n, and then the number on the end just makes the rule work. So from the Collins team, best of luck for this question.